All right, welcome. The last actual session of the day. I hope you enjoyed the conference so far. I actually did. There were a couple of slots where I was wanting to go to one talk or to two talks, and it's really a tough choice. So with that, I want to thank you for choosing this one as the last session of the day. My name is Martin. I work for JetBrains, and this talk is going to be about how we built JetBrains Rider, our IDE for .NET. Essentially, a little bit of how the sausage is made, as they say. Just look at some of the internals, some of the history behind JetBrains Rider, why we built it, how it's built, how things fit together, and all of the things that we had to build in order to make this thing work. That's a little bit of a cliffhanger, because later on you will see that Rider is actually a couple of products meshed together, and it's amazing to see that it actually works. If you are here for the term microservices, and not for the IDE part of things, then maybe this is not the right talk for you, because I will talk about microservices, because that's kind of how we set up the IDE, but it's not a microservices talk like in Kubernetes or whatever you want to look into. With that, let's get started. I can probably skip this slide if many people of you are using Rider, so quick show of hands. Anyone using Rider? Cool. Anyone used ReSharper before? IntelliJ maybe? All right, a couple of people. This is really cool. So I don't really have to show you this in too much detail, just going to show you a couple of things so we're all on the same page for the rest of the talk. So Rider is cross-platform. It's an IDE for .NET. It gives you access to writing .NET Core, .NET Framework, MAUI, Blazor, .pf, WinForms if you're on Windows. If you're doing game development with Unity or Unreal Engine, you also have Rider that you can use. If you do C++, really interesting. You can also use Rider, because we also have C++ in Rider. With all of those things, it's still lightweight. It's not lightweight as in Notepad or Vim or whatever, but it's still lightweight for all of that functionality. And it's built on IntelliJ IDEA and ReSharper. So by seeing the hands that went up, I think a lot of people recognize IntelliJ in Rider and vice versa. A lot of people who have been using ReSharper will probably also know about the shortcuts and everything that is going on there. But essentially, the goal is the same as with all of our products, trying to help you be more productive as a developer. So a really quick demo of Rider. This is Rider, zoomed in a lot, just to make it a little bit nicer on the screen here. On the left-hand side, you have a solution explorer where you can look at properties, you can look at dependencies, you can find files that are in there, you can navigate, you can open those. In the editor, you will see find usages through code vision, where you can navigate to wherever this thing is being used. You can write code if you want. If I add a void foo, I can start writing code in there. I can also see that this thing is being unused, so I can also remove this unused method again. There is Git integration, so I can commit changes. I can look at a Git log. There's a terminal. There's unit testing if you want it. There's a NuGet client. There's also this small database icon. Anyone never saw this before? This is a really cool thing, because I think it's one of the best database explorers out there for many databases. Do check it out if you haven't yet. But essentially, this is the IDE. There's lots of things, lots of bells and whistles, lots of things that have to kind of work. And as we will see later on, it's really cool that this actually works, because there's a lot of technology going on in the background. All right, that was my fastest Rider demo ever, I think. Let's look at a little bit of history. So JetBrains as a company started based on a product called IntelliJ Renamer. Back when we started in 2000, UIs looked really bad, I would say. Operating systems have definitely gotten much nicer in how Windows look and so on. But IntelliJ Renamer was essentially a tool that allowed you to rename classes and methods and symbols in Java codes. It's really strange to think about that, but in 2000, which is only 24 years ago, it was almost impossible to do a rename inside of any code editor where the code would still compile and everything would still be happy. You would typically do a find and replace, and things might break and so on. So IntelliJ Renamer, it's crazy that you can start a company built on just a tool to rename symbols in Java codes, but pretty cool products. That happened in 2000. Company was started, JetBrains was started, and so on. In 2001, that IntelliJ Renamer became a full IDE where you could write code, edit codes, do more than just a rename refactoring, and so on. And in 2004, something really scary happened in Java land. We had IntelliJ IDEA. But in Java land, Eclipse came about. And we, as JetBrains, we were a little bit worried that Eclipse might be a thing and people might start using Eclipse. So we also started looking at, can we do the same thing as we do with IntelliJ, but for different languages and frameworks, which was .NET at that point. So we started building and released ReSharper at that point. We'll talk a little bit more about ReSharper in a second, but ever since, based on the foundation of those two products, we've built a lot of IDEs. And Rider is kind of special because Rider is a combination of those two initial products that were there. Now let's talk a little bit about ReSharper. If anyone here ever tried ReSharper version 1.0? Anyone? Okay, I'm old, sorry. This is ReSharper. ReSharper was, at the time we were releasing it, so the first previews that you could download at the time, ReSharper was both a plugin to Visual Studio, but also a standalone IDE. This is the ReSharper standalone IDE. WinForms application, beautiful with the default icon still in the top left corner there. But really cool to see, this was a full-blown IDE with lots of the things that you still see in IDEs today. There's that find usages window, is essentially still there. It looks much better than it looked on this screen, but it's there. What I really want to say here is that because ReSharper was this thing that was both a plugin to Visual Studio and a standalone IDE, there was a lot of code in there to essentially support those two products. In the end, we did not ship the standalone IDE because Visual Studio was a really good IDE, and we thought, okay, they have a very rich plugin model. Let's just stop building the standalone IDE and go with this plugin. However, with all of the functionality and the fact that we built this separate IDE, we kind of had this notion of having a really good, let's call it a backend of ReSharper that could do all of the language analysis, everything that was going on in the background, with any UI layer on top. And that any UI layer in Visual Studio is, of course, the plugin to Visual Studio with menus and tool windows and all of that. But also we had our standalone IDE, which we didn't evolve, but the infrastructure was still there. By doing that, it seems that we've done a great thing there by doing that, because it allows us to, even today, still integrate with all Visual Studio versions from 2013 and up, which is, you would think, who's still using Visual Studio 2013, but there's a lot of companies apparently still using that with older code and so on. So it's really cool that we plug into that one, but also in the more modern Visual Studio versions that are there. Next to having those different Visual Studio versions that we support, we also started looking into a command line tool. Just for internal use, essentially, we started looking at, okay, we have all of these inspections in ReSharper. Can we run them on CI so that we can see how good our code quality is and so on? We released that thing, and even today, you can still use ReSharper as a command line tool, but it's essentially the same engine as that plugin in Visual Studio, but also that standalone IDE. So a lot of concepts from that time still remain and remain throughout the years with ReSharper. Keep that in mind. Fast forward many years. At conferences, we would have our booths and people would come up to us and go like, hey, JetBrains, ReSharper is awesome, but when are you guys building your own IDE? Can you please do that? And we've always been thinking like, nah, well, no. That's a lot of work, and there is already a good IDE out there, so let's not do that. However, in 2017, a couple of things happened. That question of when will you build your own IDE kept coming from a lot of people. We also saw at that time Roslyn came about. Visual Studio being a 32-bit process meant that Visual Studio was just essentially garbage collecting all the time because Roslyn needed a lot of memory, we needed a lot of memory, and things started to get a little bit fuzzy. At the same time, and by the way, that 32-bit process has been involved in Visual Studio 2022, so it's much better with more address space and more memory that's available. But still, at that time, for us, it was kind of like should we keep investing so much in ReSharper, which obviously we did, but should we keep doing this even if the environment that we have is a little bit constrained? Should we be looking at other options as well? There were also some changes in Visual Studio that were impacting ReSharper, like the high DPI support, for example, when you would draw screens and everything, is slightly different from the default that you have in Windows and how it works. So we had to do a lot of changes to keep that working, but then also backport those to other Visual Studio versions so that it didn't blow up at that point and so on. So we were really in this mode of, okay, let's keep building ReSharper, but let's also think of an alternative. Also at the same time, .NET Core came about, which was interesting because it ran cross-platform and it was on Mac and on Linux and on Windows and everything. And we thought, okay, there's no IDE that is cross-platform on all of those platforms. That is the exact IDE. Yes, there was MonoDevelop at the time, which later became VS for Mac, which is now deprecated. Visual Studio Code was there as well, but nothing that was exactly the same IDE across all platforms. So we thought, okay, we have an opportunity here. We have all of these things that are happening at the same time. Now is the time to finally see if we can build an IDE. But for cross-platform, which was one of the things that's also pushed us in this direction, a cross-platform UI toolkit would be needed. ReSharper, the UI, is all built in WinForms, or was built in WinForms. There's still some WinForms in there, but most of it has been ported to .pf right now. But that UI was there, and .pf and WinForms weren't really available on other platforms. Yes, you could do it with Mono and Linux, for example, but it wasn't exactly the same, and it was really hard to just port that over. So if we wanted to build cross-platform, we would have to rebuild the entire ReSharper UI to make it work there. Go with full WinForms. Well, again, Mono has it, but it's not actual WinForms. Go with one of the Linux frameworks like GTK Sharp, Qt, something like that. It essentially, again, means rebuilding the entire IDE or rebuilding the entire UI, which is not something you do easily. But then we started thinking, I didn't upgrade the background there, nice. We started thinking, we have IntelliJ, which is our Java IDE, and that runs on Windows, on Linux, and on Mac OS, and so on. Can we reuse that? Because we've built a lot of IDEs on that platform. We know how this works, because this is what we do on a day-to-day basis. Can we reuse some of that for Rider, the IDE that we wanted to build? IntelliJ platform, as I mentioned, is the foundation of all of the IDEs in JetBrains. It comes with a lot of the default things like a project view, editors, documents, code completion, version control is in there, the terminal, and so on. That is open source. And then for our IDEs that we ship as commercial IDEs, we ship essentially JetBrains-specific plugins that try to bring us the revenue. It is open source. Actually, Google builds Android Studio also on top of this IntelliJ platform. There's Cursive, which is a Clojure IDE that you can also use. That's also a third-party product using the same base. And we thought, OK, we already have all this. Let's see if we can reuse IntelliJ platform as the foundation of our .NET IDE. Already cross-platform, thanks to Java's write once, run anywhere approach with how things work. Another problem, of course. IntelliJ platform was JVM. It was a great UI framework, and we could use that as an IDE. ReSharper, however, was all .NET, with all of the .NET C# parsing, VB.NET, F#, etc., but also runs on .NET. It needs .NET to run. The front end is JVM. Like, how would this work? How can we bring all of the functionality from ReSharper into IntelliJ platform? So one thing you could do, and I guess everyone at some point in their careers has wished you would do that at some point, and is just rewrite everything. But we all know that doesn't work, right? So we thought, OK, rewriting ReSharper in Java is going to be a really hard job. It's going to take a lot of time. We have that knowledge. We have all of that implementation details and so on. But essentially, it means rebuilding ReSharper in Java, which is probably not a good idea. We wouldn't be JetBrains if we also didn't attempt to automatically convert C# code into Java and then try to make that work. We kind of tried that, but also didn't really work out, so that was not really a good idea. But then we started thinking, OK, from our early history, we have this ReSharper that we can run as a command line process. Can we run this and then just hook up a UI? And that's between air quotes, because just do this is something that also doesn't really work in IT, but it was a good idea. So we did that. We decided to go with headless ReSharper as a language server, cross-platform, because it could run on Mono at the time, or on .NET Full Framework on Windows. Would work on Windows, on Linux, on Mac OS, etc. Nowadays, it's much easier because we have .NET 8, and that just runs everywhere. But at that point, cross-platform was an easy choice there. .NET would run cross-platform. No constraints, same code base, so we wouldn't have to maintain 2 code bases to keep ReSharper running. Essentially, just make sure that we have this running headlessly, and we can use that from our UI. And then the idea was to use IntelliJ as a thin UI on top. Essentially, just something to boot up that ReSharper process, communicate with it, and show whatever ReSharper wanted to show on screen. However, and this is a talk about many hurdles during that entire process, is IntelliJ IDEA really a thin UI? It is a full-blown IDE, right? And in the end, we started thinking, okay, we have this UI which has version control, terminal, all of those things. We have ReSharper doing things. IntelliJ can actually handle HTML, CSS, and so on. But then ReSharper does Razor, and that is kind of HTML and CSS and maybe even JavaScript, but also C#. Like, how would all of this work? How would all of that fit together? And we identified there's essentially 3 sorts of features that would end up in this product that we would build. Namely, features where the front end would handle everything. Like if you do a git commit, that's essentially all IntelliJ taking care of that. If you work with the terminal, same thing, that's all IntelliJ doing that. There's a couple of cases where ReSharper would handle almost everything. Like if you do a big refactoring, it's let's say a rename refactoring, for example, ReSharper would do that refactoring in the background, write stuff to disk, and then tell IntelliJ, hey, you have that document open, maybe reload so you can see the changes that are in there. And then, of course, a couple of features where having both IDEs together, combining their functionality, would also be interesting. So let's look at a couple of examples there. Just to sort of situate what we mean by having all of those combinations that are there. So in this grocery lists API project that I have here, actually, let me go into the other project that I have here. If I would open a Markdown file, let's say readme.markdown, that is all IntelliJ. The editor you get here, everything you see here is all IntelliJ because IntelliJ knows about Markdown. It can show you a preview on the right, spinning up a Chrome process underneath or a Chromium process underneath and showing that in the IDE, and all of that just works. All of the editing functionality here, if you would Alt-Enter here and say, okay, look, sorry, Command-N to create something new. No, wrong place. Fine. If you would do something like create a table or something, let's quickly see if that works. My Markdown is broken. Great. Anyway, typically you would see something pop up here where you could edit this table and work with that. This is really the demo effect. But all of that functionality, which is right now imaginary, let's make this bold. Okay, at least that works. That's all IntelliJ. No ReSharper is involved in any of this at all, even though still this is Rider. There's a couple of other places where more interesting things happen. So if I would go to any CSHTML file, you will see that this is HTML, and we actually power that by IntelliJ because IntelliJ has really good HTML and CSS and whatever support. But inside of that HTML even, we all of a sudden have C#, where we do some add statement and do something with Razor. At the top here, you see page, usings, models, some C# code, etc. If I wanted to start writing an if statement in there, I could do that, and all of this kind of works together. So this is really IntelliJ and ReSharper powering the same document at the same time. All of those squiggles, by the way, that's probably IntelliJ now freaking out because something is wrong in the structure and I don't have any braces there. There we go. But that was IntelliJ actually showing you all of that red code and saying, look, this is wrong. That's not what you want. Even more, if I would navigate to Solution Explorer, that's IntelliJ. That's functionality that's in IntelliJ. But if I would go into this HTML or in the C# code that is there, this is C# powered by ReSharper. The usages here are powered by ReSharper, but then the fact that I wrote this code apparently comes from the Git integration, which is again IntelliJ. So even in this C# file, we are surfacing some things from the front ends. Maybe in this other project, I can show you something really cool, actually. I mentioned there's database support. The moment you have a database connected to your codes, you can do something like this. Let's uncomment that code. Yep, there we go. Let's rename that one. You see C# codes. But in this C# string, I get completion for SQL. If I would start writing in there, you would actually see that the completion I get is based on my database that I'm connected to, etc. Just that bit inside of that string is IntelliJ functionality. Everything around that is ReSharper powering the rest of this C# file. So again, there's lots of things that play together. And this is really something that we wanted to have from the beginning when we started building Writer. Like, try to be able to reuse whatever we have on both sides, because both sides are an IDE and have all of that power. So just start to think like, how complex can this be, right? Because there's a lot of things at play. So let's look at that. How do you make the IDEs talk? How do you make the data flow so that we can actually have those powered by one, powered by ReSharper, powered by both? How do we combine all that? We started looking at the things you use mostly in the IDE. So typically, you would open up a document where you see some C# code and so on. At some points or some line in code, you press Alt-Enter, and you want to see what's going on. IntelliJ provides you with the editor, the Alt-Enter key binding, and it knows that a document is typically of a specific programming language. ReSharper in the background knows about C#, contributes, inspections, and actions, and so on. And IntelliJ then renders all of the actions that you see in the Alt-Enter menu that is there. We started thinking, OK, if we do like a request response, we can get back all of that data. But if you really start analyzing what has to go over the wire, essentially, between the two processes, is some data to render something in the UI that has an ID, so we know which action to trigger, maybe the name of a node so that we know which thing that is, and so that we can set the icon, for example, and that's pretty much it. So essentially, build up a tree of whatever should be shown in the Alt-Enter menu when we press Alt-Enter. And that data can come from IntelliJ or from ReSharper. We'll look later at how we combine both. But essentially, we started thinking, OK, that's a lot of features going on. But in essence, it's essentially a tree of ID, name, and an icon that we want to display there. Same thing with inspections. Like if you see a squiggle there where you see, for example, possible null reference exception, again, IntelliJ brings you the editor. It gives you the ability to put squiggles underneath specific symbols. ReSharper would power all of the C# that is in there. Would power all of the inspections, show all of the actions that are available, and so on. And IntelliJ would then again render those. Also here, digesting everything, the data to render those squiggles inside of a document is essentially, again, a set of the name of the inspection, maybe an ID of the inspection, the severity, so that we can change the color that is there, the tooltip that we should show up, because typically the UI is going to have a more detailed tooltip and a smaller Alt-Enter menu, for example, and the text range that should be highlighted in the document. So again, not a lot of data. Writing codes, that was actually the most difficult one to think about, because it is bidirectional. The user can be typing codes, but at the same time, you might have triggered, let's say, again, a rename refactoring, and that rename refactoring can take 2 seconds on a really big solution, but maybe you are still typing at the same moment, so the text input can actually come from multiple locations at the same time. But again, digesting this, it can be implemented using a delta approach, where essentially each side, whether it's IntelliJ saying, OK, the user is typing, or ReSharper saying, I'm updating the document after refactoring, both sides could essentially push deltas into the system. Say, OK, from this line, this column to this column, this is a text that I want to see there. And essentially replay all of that like you would do with say, a message bus, and essentially just look at all of the deltas and replay so that you can build the entire document that is there. More complex, but in the end, still simple enough, or yeah, simple enough, I'll put air quotes there, to start looking into how can we generalize editing text or writing codes inside of the IDE. So the data types are not that complex. They're fairly simple messages. And we started thinking, OK, let's not go into specific refactoring, specific alt interaction, specific whatever. Let's see if we can make this all generic enough so that if we finally make it so that one inspection shows up in the editor, that all of them will show up. So we started working on that and really digesting all of the flows in the IDE to see, can we make this data simple enough so that it could work? Then the next question came about. And again, lots of hurdles along the way. how do we communicate between IntelliJ frontend and ReSharper backends? So we looked at Visual Studio Code at the time, which also came about, which has this really nice protocol called the Language Server Protocol. Anyone familiar with it? At least heard of it? Yeah, cool. So LSP is essentially a protocol that does exactly that. It is there to talk to a backend service about stuff that happens in an IDE. It's really great. It has IDE concepts like a workspace, like a project or a solution or whatever you want to call it, documents and editors, languages, diagnostics that you may want to show in the IDE, and so on. However, LSP it's a cool protocol, but you see it's built for VS Code. And some other IDEs might be reusing it. If you're using Emacs or Vim, you can also use LSP to talk to a backend and show some more interesting things in the editor there as well. But it is really focused. It's a VS Code implementation, essentially, which meant looking at the stuff that ReSharper is doing and IntelliJ is doing, we thought, OK, we will need to customize the protocol a lot because we cannot push every feature over the wire. And essentially, we want to get the best of both products and not some subset of whatever is in there. LSP, really cool, also allows you to do customizations and extensions on top of that protocol and so on. But we thought, OK, if we have to, from the start customizing this thing so badly, maybe we shouldn't use it and build our own thing. Also, at JetBrains, we like building our own thing, so that's another reason. So we decided, OK, LSP is this REST-like protocol, even though it works on input and output of two processes, for example, and you can use it over HTTP. But it's a REST-like request-response protocol that goes over the wire. So we thought, OK, let's mimic that approach. Let's do something similar there and experiment with a couple of message types that can go over the wire. So we tried JSON, which proved too verbose and too big to put over the wire to have quick responses in the UI and so on. We looked at protobuf, which was also not great because you would have to essentially rebuild the binary model there over and over again just to have wire compatibility. We looked at custom request response with APIs that made sense for a particular scenario. So something could use JSON, something could be, let's call it CSV, but essentially just a text stream of things going over the wire. We looked into virtually every option that was there and essentially found this is kind of hard. But we also started thinking, looking at LSP, which is requests, do something, get a response back, like you would have many web APIs out there, is kind of weird if you have an always running desktop application where you have in-memory and so on. Like, why are we even doing this pattern of request response? Also, every call for LSP would need contexts, like which workspace is open, which file is open, what's the delta, and so on. Even for very simple things where you wouldn't really need that information, LSP would need that. And also, if you do request response and you want to keep it as stateless as possible, you would also have to pass in that context as well. So we started thinking, is request response really the good approach to this? And we had a realization where we said, look, IntelliJ follows this structure of documents and inspections and so on. ReSharper, back when we built it in 2004, used a lot of those models in building ReSharper. So it's essentially a very similar architecture, essentially. Can we somehow capitalize on that? Because both models are 95% the same. Can we just talk between the two? So we started thinking, there's this cool pattern, MVVM, where we could have a protocol which is essentially a bunch of collections where both ends of the spectrum, IntelliJ and ReSharper, can push in data and read data from, subscribe to events that are going on, and just update whatever information they need on either ends. So the general idea, and this is pseudo codes, but essentially the idea would be you have a project collection would have a files collection, and you can say, add me a file called foo.cs, and both sides would know, OK, we need a new file, open up an editor, or something like that. In that foo.cs file, I could also index that on that projects and files collection. There's an inspections collection on there, and I can just add something in there saying potential null reference. It's a warning. It's on line 20 from column 30 to column 20. I don't know what I meant with those numbers, but anyway, essentially making sure that we could just add something to a collection and it would magically appear on both sides. And both sides would be observers of that model that is there. Like in MVVM, you would subscribe to changes, look at collections that are being changed, and just update whatever is there. Again, a hurdle. Changes to the data in that shared model can come from IntelliJ and ReSharper. Anyone who was in Daniel's talk before has seen that memory management and race conditions and garbage collection and all of that can maybe potentially slow down your process. And having two processes running at the same time means that garbage collection can happen in two processes at different times, and maybe something in ReSharper doesn't trigger at the right time for something added into a specific collection, and vice versa. There could be timing issues with IntelliJ saying, I just deleted this specific file, and ReSharper saying, hey, I just refactored that file. That's 1 millisecond difference. Who wins? Who is right? So we looked into that and we thought, okay, we could do locking. Like if IntelliJ wants to work with foo.cs, let's do a lock so that ReSharper cannot write into that thing. That's great, but also not so great because it might lead to freezes. How do you handle deadlocks with multiple processes working on this and so on? Some more backgrounds. IntelliJ and ReSharper each individually have the concept of locking as well, so they can take a read lock on a file and a write lock on a file. But again, combining those between those two products would be very, very difficult because then you would have not only deadlocks, but potential distributed deadlocks, which is not something you want. We made a tough decision there, and also a naive decision, which in the end proved to be a good decision. And that is essentially go with a last one wins approach. So whenever we store a value in the view model, there's a version number, and we simply increment that one, and the latest version wins. So if IntelliJ says, I deleted a file, and that's version 2, and ReSharper says, I refactored that file, and that's version 3 at the same point in time, ReSharper wins, the file is still there and is refactored. It's not deleted. And IntelliJ recovers from that and knows that that file is there. You need that versioning. You need that communication, you need this view model and so on. So we decided, okay, let's start investing into this entire protocol of how this thing could work. So nice diagram, especially nice because the word magic is on there. That's what we all like, right? We have Writer, we have ReSharper. Writer is IntelliJ JVM, ReSharper is .NET, at the time still mono. We want some magic in between that crosses the boundary of two processes, inter-process communication or whatever we are going to use in there. And our developers building features in the IDE should not care about what's going on at that point. They should know it's there, and they obviously will have to do some things, but they shouldn't all know all of the details of this entire protocol, what is going on under the hood. So for example, that versioning, our developers shouldn't care about the fact that that versioning is there. They should just be able to write a file, and this magical thing in between should solve things. So we came up with the Writer protocol. It's open source. If you want to use this thing, it's kind of specialized and opinionated, but you might get some use out of it. It's a reactive distributed communication framework for .NET, Kotlin, which is JVM, JavaScript, and C++. .NET, because we needed it in ReSharper. Kotlin, because that's our language which runs on the JVM, and we need that in IntelliJ. JavaScript, just for the fun of it, and C++, because we also have ReSharper C++, the profilers do some C++, and so on, so we also needed that thing. Open source, and it's essentially an entire toolkit of a couple of things that you can use. Lowest layer there is sockets, batching, the binary wire protocol, everything that goes over the wire is part of the Writer protocol. You don't really have to care about that, but it's in there. The conflict resolution, the versioning, all of that is also in there, but again, you don't really have to care. You as a developer using this protocol, or our developers building Writer, have to start knowing about all of the primitives in this protocol. Like there can be strings, there can be fields, there can be classes and structs and all of that. The DSL that we have to essentially build out a model of whatever you want to build in this view model, which is the protocol, and then the fact that there's a code generator that you have to run to essentially build a .NET version or a Kotlin version of the end result of how you work with this protocol. So essentially, as a developer, you include the protocol libraries, which we already have in all of our IDEs, so people can just start using them. Our developers start writing that view model, using that special DSL, generate some code, and then work with the generated model, and magic happens. So they only need to know about the data types and create that model. The code is generated then based on that view model, and I'll quickly show you in a bit how this all works. The fact that we generate that code based on a view model, or that we create this view model generated from a DSL that we have, means that we also don't have to use reflection on things. So we don't have to think this is a list or a string or whatever. We just know that it's a string because we generate it up front and everything that is in there. For the writer protocol inside of our IDEs, we also implemented hierarchies and lifetimes. This is a small thing there, and you are probably wondering, what the hell? It's a core concept to our IDEs and a core concept to how we manage memory and so on inside of the IDE. Before we go there, cliffhanger again, let's talk a little bit about the primitives that are in the protocol. So in the protocol, you can define that you want to have signals, essentially events. When someone clicks a button, you can have a signal where ReSharper, for example, could subscribe to that signal, and IntelliJ could trigger the signal, and the protocol would essentially make sure that ReSharper knows that someone did some events. There's a property, which is essentially signals that go in both directions, because you have getters and setters, and you can subscribe and everything. So property is essentially a signal that goes both directions. There's a couple of collections that you can use in the protocol. There's lists, sets, maps. There's immutable lists as well. There are fields that you can use, like properties, but without the notification on the protocol. There's calls and callbacks in case you need something like an RPC call that is there. And then typical primitives that you would see in all programming languages like bytes, integers, etc. And then some class definitions, struct definitions. Doesn't really matter too much. We'll see in a bit how this looks like in reality. The protocol model is defined somewhat like this. So, for example, for the NuGet client in Rider, we have an RD for the protocol, RD, NuGet hosts, which extends the solution model that we have, and the extension, the generated name in the generated code is going to be NuGet hosts. The DSL that you see here is Kotlin. A nice aspect of Kotlin is that you can kind of create extension methods and sort of hide the fact that you need to write public, private. So you can really make it very condensed in how you define whatever is there, but this is essentially Kotlin code defining what this protocol model looks like. In the constructor of this object, init, that's the constructor, we are defining the fact that we have a property called log, which is a sink, so it takes data. And that data is going to be modeled as an immutable list of a class called RD NuGet log message. It's not a class, it's actually a struct. The RD NuGet log message, in turn, is a structure definition, so a struct with two fields, a timestamp and a text. We can make them nullable, we can make them async if we want, but essentially this is how you would model some functionality, build up the view model that ReSharper and IntelliJ can work with. We have signals and events. Essentially, observer, observable, producer, subscriber, whatever you want to call it, that you can use in there as well. Events, I mentioned hierarchies and lifetimes before. Events are also bound to a specific lifetime. So you see in that advice method on there, for example, that a sync is listening for events that are happening. They can invoke a handler function when they are still in a specific lifetime. I'll go to lifetimes in just a bit. Properties, same thing. Properties have a value, and I mentioned that a property is really a bidirectional signal. They have an advice where they listen to a change that is happening and can invoke a handler. They also have a view, where they can also have a handler looking at the data that is there and respond to that if needed. And again, you see that lifetime that is happening there. What is this lifetime and this hierarchy that I'm talking about? Both sides of the IDE, both IntelliJ and ReSharper, have a project model. In IntelliJ, that is a project. In .NET and in ReSharper and so on, that's called a solution. But essentially, it is the definition of the workspace that we are in and the thing that we are working in. Inside of that hierarchy, underneath that project, inside of that workspace, IntelliJ keeps track of local history. There's a NuGet tool window that is being shown, while on the ReSharper side, there's a NuGet host listening to whatever has to be provided and so on. There's projects on both sides. There's editor tabs in the UI. There's documents in the background in ReSharper. Essentially, you see that there's a hierarchy of concepts that map from left to right, from IntelliJ to ReSharper, from ReSharper to IntelliJ, and that are hierarchical. And also, they subscribe to a lifetime, which means that, for example, if I close a project, the entire hierarchy underneath of that project's hierarchy is going to be destroyed. So if you want to do garbage collection, for example, if someone closes an editor tab, we know that on the IntelliJ side, we can get rid of all of the inspections, the language, the editor tab itself, and so on in the UI. And on the ReSharper side, we can also forget about the fact that we have a document open with inspections with our internal representation of the entire PSI that is in there, and essentially just close that. Essentially, this hierarchy and this lifetime means that we don't have to write using statements, which would be very complex with long-lived objects, and you have no idea how to manage the object lifetime of things in memory. And instead, we have these lifetimes, which are, roughly speaking, the code that you see on the slide there, a stack of resources. Whenever you attach something to a lifetime, we push it in the stack. Whenever a lifetime is being disposed, we walk that entire stack and essentially dispose every object that was subscribed to this lifetime. Which means if you have event handlers listening to changes in a specific document, if we close the lifetime of the documents, those event handlers are also subscribed to that lifetime, and they can just be removed from memory, and we don't have to keep them in memory at that point in time. These lifetimes are also open sourced, but essentially they are a more hardened version of the pseudocodes that I have on the slide here. But it's a different approach to using disposables, where you don't have to write using statements and essentially keep track of everything. You essentially have a lifetime, and the lifetime will manage the lifetime of all the objects that are subscribed to it. With that, let's look at some actual codes in the product. Let's start in IntelliJ. This is a definition of that NuGet host that we have in the source code. So before we go into the codes, let's look at the implementation of something in the NuGet tool window. So if in a new solution in Rider, I open up the NuGet tool window, manage NuGet packages, yes, and I say, for example, I want to install Entity Framework Core. When I install it into my project, you will see that in the log of the NuGet tab here, you will see all kinds of messages that are coming from the NuGet client, essentially trying to restore or install that package. Very simple example. Now, how does this work? Because this is, of course, UI in IntelliJ, essentially Rider, and something happening on the .NET side in ReSharper to restore that NuGet package. So how does this work? We have a model that defines all of the NuGet operations. And by the way, is this big enough? Because I can probably zoom a little bit if you want. This is all Kotlin codes. We define an object, which is essentially a singleton, defining a singleton in Kotlin that is called RD NuGet hosts. We extend the solution model because, again, we are bound to the lifetime of the solution, so we want to extend the solution in this case. And we have this extension called NuGet hosts. In there, we have a couple of things, and let's just search for it. There should be a log sync that we are defining, and that we say, look, this is a list of RD NuGet log message. RD NuGet log message, if I navigate there, is essentially a definition of having a struct with fields that are a timestamp, which is a date time, a field that is the context, which is an enum called RD NuGet log context. That can be NuGet, Rider, build, etc. A log level, a couple of other properties that are in there. Nice thing about having this protocol model defined in Kotlin is that we have a Kotlin IDE, IntelliJ. So you get things like navigation. You can search for usages of, for example, where are we using datetime. You see if I hover, I can go to the enum definition, like what is this thing doing? But essentially, once we finish the model that we have here, let's zoom out again, we run a code generator that will essentially instantiate this entire model, so this entire object, just call all of the methods that are in here and generate the wire protocol for both Kotlin and .NET. On the IntelliJ side, the generated code will be something like this, with all of the things that were generated with version numbers so that we have binary compatibility on the protocol and so on, class loaders, all kinds of Java-specific stuff. But at some point, our log property, where is it? Should be there somewhere. It's this one. Our log property is a signal. I told you that properties are bidirectional signals. That contains a list of RD-NuGet log message. But in this case, it's no longer the protocol definition. In this case, it's really generated Kotlin code. So if I look at that RD-NuGet log message, for example, you can see that this is a data class, essentially like a record type in C#, where we are defining that we have this timestamp, which is a date, an actual Kotlin date, and not just something represented in the protocol. We have a text, which is an actual Kotlin string, so it's a native type that we can use everywhere. It implements iprintable, and there's a couple of things in there that handle how this is bound to the protocol. But essentially, our developers define the model, we generate the codes, and then we work with that generated code. So we don't really have to care about everything in here. Just wanted to show you that on the Kotlin side, we generate all of these Kotlin codes. Now, if we look at the ReSharper solution, and I should have opened this one beforehand, but let's do it in here. On the ReSharper side, we do the same thing. From that Kotlin model, we also generate the C# version of that code. So also here, and this is a big project with many, a big solution with many projects, so it's going to take a couple of seconds. But if I search for the log in here as well, you will see that in here also, we have a public field called log, which is a list of RD-NuGet log message and some protocol-specific stuff to fire this event into the protocol. But if you look at that RD-NuGet log message, for example, come on, it's still loading. Let's just search for it for a second. You will see, where is it? Let's try it again. Great, let's do that in a little bit. But essentially what you would see is that this RD-NuGet log message in C# is also going to be an enum, or going to be a struct, because we defined this as a struct, and it's going to contain the same string, or the same text that is a string, the same date time, the timestamp of the log message, and all of those things. Is it really still loading? This is the curse of having many solutions open on the same machine and being connected to a projector. Getting the action ready. Anyway, let's skip this one. In the UI for the NuGet log panel, which looks like this, we have this NuGet log panel where we have this RD-NuGet writer NuGet facade, which is an object that wraps the protocol, etc. But essentially, what will happen is somewhere in there, I should be using that log. Yes, there it is. There's an add message method that is being called, where I can push in a message. If the message is not empty, we are writing it to the, using print, writing it to a string, and then showing it in the UI. Where am I using the log, or where is my sync? That's the full log, right? Yeah, there it is. So from this NuGet hosts and that facade, I'm getting the full log. That is actually that one generated property, which is my collection. But from my full log, whenever that changes, somewhere I'm subscribed to that, and I say reload all, and I just iterate over that full log, add messages, and show them in the UI. So not much more than that is happening. Essentially, subscribe to the list in the protocol and do something with it on the IntelliJ side. On the writer side, and by the way, here's my writer NuGet log message now, again with a date time, with a level, with the text, and so on. On the writer side, or on the ReSharper side, I have a NuGet logger, which also subscribes to this NuGet host, so it knows about the protocol and works with that. And whenever the NuGet client that we reuse from the NuGet packages wants to send a log message, what we are doing is using that log collection, and we are firing in a new NuGet log message with all of the properties that NuGets want to pass in. So it's very lightweight. It's a very simple protocol where We only essentially have to interface with NuGet in this case, listen to messages that NuGet is emitting, sending them on the wire, and then doing something with them in the UI. So does that make sense so far? Hope it does. Cool. You'll also see the lifetimes here. So another tab that you will see in the NuGet client. So if I go in here and go to sources, you will see all of the NuGet sources that are defined in your NuGet configuration. That lists, a good example is in here. That is making use of the lifetime there as well. So this lifetime is reused in many places where, for example, for logging into NuGet, for showing those sources and so on, we have a bunch of objects that are subscribed to this lifetime. And again, when I close the entire solution, the lifetime is going to walk its stack and just destroy everything that was subscribed to that specific lifetime. So it's, again, quite useful. All right. Any questions on the protocol? I can go into detail if you want, and if you really want to start using it, we can go into a lot of detail, but just wanted to show you, write a model, generate code, and then just work with the generated code, and something under the hood handles everything. So we found this is actually a really nice way of working because our developers, again, don't have to know about all of the internals of the protocol. They don't have to think about state, conflicts, or whatever. Again, generate the model, work with the model, and be done with it. It's cross-language, cross-platform, so it means that you can use C# code or C++ code, push something in the protocol, and then IntelliJ can subscribe to that and show something in the UI, for example. One downside, the plugin model for Rider. Anyone ever tried writing a plugin for IntelliJ? Nope. Then I guess for Rider is also not, nobody's going to put their hands up. It is hard because it means if you're building a plugin, you as a plugin developer also have to think about the fact, do I want this just in the front end? Do I need the resharper engine as well? And if I need the resharper engine, do I also want to surface something specific in the front end or not? And maybe even build my own protocol extension. Luckily, a lot of the things in Rider are open source, so if you want to look at how we implemented F#, for example, you can find a lot of inspiration, but you will see also in those plugins that there's this same structure where you have the model, it's generated, and then both ends of the plugin can essentially contribute to the full-blown behavior of that plugin. But it's more complex, definitely. Right, with 8 minutes left, let's talk about microservices. I know it was the keyword of the title of the slides of this presentation, but let's finally talk about microservices. Rider is two processes. We have IntelliJ, we have resharper in the background, and this is awesome because it means that both of them are isolated. If IntelliJ crashes, well, then yeah, there's no UI anymore, and you have to restart Rider. But if something in resharper would crash, for example, IntelliJ in Rider can essentially just restart the process. And apart from maybe a little bit of lag, you don't have to care about that because we can manage those processes, and things will keep working. What's really interesting from a technical side is that they're both their own 64-bit process with their own garbage collection. Has a couple of downsides in that both of them might be unresponsive for a couple of milliseconds every once in a while if there's a lot of GC happening. But it's quite cool because we don't have to synchronize whenever something happens and so on. On multi-core machines, this also means that each core of your machine can be running some resharper and some IntelliJ, so we get really good multi-processing and multi-threading based out of that. And again, we can start and stop those processes independently from one another. If you are debugging your C# projects in Rider, you have Rider itself, which is the IntelliJ process and the resharper process. You are launching your own application, which is a process in itself. And we are actually also launching yet another process, which is our debugger worker process that listens and works with the debugger interface in .NET in your application, but also pushes data into the view model through the resharper side of things. So if you're debugging, you have 4 processes running, working with your application that are going on. Again, interesting there is if the debugger fails for some reason, we can restart that process, or we can just say, okay, it's broken, restart debugging or whatever, without impacting the IntelliJ side and the resharper side of things. So that's also a nice benefit there. This, however, got us thinking. If we can spawn these processes, if all processes can contribute to this big view model that we have in the protocol, what else could we do? One of the things that came out of that was our .pf editor on Windows. Anyone using that one? Yeah, one person, cool. There's a preview of your .pf that you're writing. So you write the XAML, and then you get a nice preview down there. The XAML, again, is ReSharper powering the XAML. The UI is IntelliJ essentially showing whatever ReSharper is doing. But the preview down there is a separate process that we launched for just that one specific XAML file that renders the XAML and pushes a bitmap over the protocol that the IntelliJ UI can subscribe to and then display in that tool window. Really cool, because .pf can have lots of exceptions or whatever. The previewer might crash if you use a third-party component that needs other dependencies that are not there and so on. It's very tricky. We don't care because the process crashes and we can just show you, yeah, there's no preview, something is off there, without, again, impacting everything else in there. Multiple processes. Anyone tried the latest version of Rider, released last week, I think? Yeah. The monitoring tool window that you see on the right-hand side there is pretty cool because it kind of profiles your application while you are running the application or while you are debugging. If you think about debugging, which is already 4 processes, IntelliJ, ReSharper, debugger worker, your application, this one actually adds another process, which is our profiler process that listens to both your application and also integrates with ReSharper and just pushes things on that view model that we can surface in the UI. We also have support for Roslyn inspections. We actually have a process that starts whenever we detect that you are using Roslyn analyzers in your codes, and we simply start that one up, build the Roslyn workspace, and all of the diagnostics from Roslyn, we essentially push on that same view model and say, look, there's an inspection there triggering, there's a quick fix that you can trigger as well, and again, another process that runs. If Roslyn fails or you're using a preview.NET version and we're not yet compatible with that, doesn't matter. Some functionality will not work, but it doesn't impact anything else that we have in the IDE there. You can actually see that if you run Rider and you look at the Process Explorer, you can actually find that if that Roslyn icon shows up in the Alt-Enter menu, you will see that there's another process running, which is our Roslyn worker, which has its own view of what your project looks like. Being able to do this on one machine is cool. But the protocol is also a wire protocol. It can work on sockets, it can work in process, and so on. So if you are doing remote debugging or debugging on Docker, we actually run some of the processes that integrate with the model on different machines. If you debug in a Docker container, the debugger worker process is also running in the Docker container, but still communicating with ReSharper and IntelliJ over that same wire protocol and essentially just pushing data in that view model. Unity, same thing. We have a process there that listens to Unity and connects to Unity and works with your game that you might be building, which is quite cool actually because we can do things like this. You see the small gray code there. If you're building Unity games, you typically build the graphical side of your game and you hook it up to the codes that you have sitting in behind. Well, we can get data from Unity where you can see, okay, this cooldown period, for example, is being set in Unity. We can do things where this laser, for example, is bound in Unity. And because we run the RD protocol inside of the Unity editor, we can show you find usages from within your codes inside of the Unity editor. And again, just by contributing to that model that we have underneath. Code with me, anyone tried that one? The collaborative code editing that we have in our IDEs. Code with me works brilliantly in all of our IDEs except Rider. I'll go into that one in a minute. But Code with me is essentially the Rider protocol that we've reused for all of the other IDEs, where we have a view model that just talks from IntelliJ to IntelliJ or WebStorm to WebStorm, and where both sides of this collaborative code editing session or 10 sides of this session can just connect to the same protocol message or to the same protocol that is running and just push stuff into the view model and all of the parties subscribe to it. Now, I mentioned that Rider is not yet supported here. We have some preview support that is going on. Code with me takes all of the learnings from Rider and is actually working on a newer version of this entire model than Rider currently is. We are working towards that, but that's the reason why it's not supported yet in Rider. Also cool is that you can write plugins for Code with me, again using this RD protocol. So actually, together with a colleague, built an asteroids game that you can play inside of IntelliJ multiplayer. The frame rate is horrible because this thing is not made for these kinds of scenarios, but just wanted to show you you can write plugins that work even with Code With Me, just extending that protocol where you can play together inside the IDE in this case. And again, the frame rate is terrible, but here we are. Remote development, same thing. You connect to a remote SSH server and you work with it, same protocol. There is some future and side effects from all of this. If we can run on multiple machines, can we maybe extend how we work with this? What if you want to build a .pf application while you are working on Linux or Mac OS? We could essentially preview and compile the .pf code on a Windows machine, pipe it through the protocol, and show it on your Mac. We're not there yet, but it's one of the scenarios that we think, this might make sense as a feature, and that is something useful. Having every IDE as both a client and a server is another thing that we are thinking about. Not building anything in that direction yet, but it's something that we're thinking about where, for example, in ReSharper, we could bring WebStorm as the engine to power all of the web features in ReSharper, which would be really cool because then you have Visual Studio with the ReSharper plugin running WebStorm inside and using that protocol again. So a couple of things that we're thinking about that might be useful, and again, just reuse that exact same protocol. Modeling the view, this is one that we're actually doing already. A lot of the tool windows that you will see in Rider and ReSharper nowadays are built using a protocol or a DSL that we built on top of the protocol, where we can say, okay, we want to show a text box, we want to have a button that subscribes to this handler, both on the IntelliJ side and on the ReSharper sides. We can model that UI in this small DSL and just render it both in ReSharper as well as in Rider. So that's pretty cool, and we're getting more and more towards building our UI using this DSL that talks to the protocol as well. So in summary, Rider is an IDE built on 2 IDEs and 2 technology stacks. It's really hard to bridge JVM and .NET, but we did it in this case. We built this protocol, and that protocol gave us the option to do many, many more things than just build Rider. I know this talk is probably not going to be something that you use in your day-to-day work and whatever, but I do hope that you enjoyed to see how at least a little bit of the sausage is made. Thank you very much. Good questions. Thanks, Daniel, for the hard ones. Why has JetBrains decided to build their own observable model instead of using an established model like RX? Well, also there, the reason is that if we would have used RX, which would be a good thing because it is kind of the same approach to things, we would still have to build a way to model what the protocol would look like, do some code gen that then in the end would use RX. And we thought, well, if we have to build all of this ourselves anyway, let's also make something that works specifically well for our use case and not go into RX and maybe support things that are harder to do in Rider versus just having our own version of such a framework. Hope that makes sense. Cool. Have you heard of the concept of view model composition? If yes, would you say the Rider protocol is an implementation of that pattern? Yes. So view model composition would essentially compose the view model of different view models that are there. If you look at the protocol, the fact that, for example, that NuGet client was extending the solution view model, it means that the NuGet client is a view model that lives inside of the bigger view model and essentially like that contributes to the entire thing. So I would say yes. All right. Any more questions, feel free to come over. And if not, I wish you a great panel after this session and a great rest of the weekend. Thank you.
Yes. Hey, cat sure got a groove going on here. Kinda reminds me of the Squire. See, he always called himself the Squire for hire. Oh yeah, folks would come from miles around hear what the squire was putting down. Now you know, the squire always had a secret smile on his face, like he was listening to some other song in some other space. Ooh, ooh, what a groove. Now everybody loved to be hanging with the squire for hire, 'cause when he was flush, had some coin in his pocket, now the party was on. Now sometimes the squire had to make a square gig, you know, maybe some birthdays, even a little convention or two. But boy, when he was through, he always knew where he could go to blow. And I do mean blow. Now, another thing about the squire for hire were the threads on his back. Ooh, solid, Jack. From his head to his feet, no other cat could hardly compete with the squire. Now, the last I heard about the squire for hire, he's still on the scene. He's playing his acts and he still is mean, y'all. So now if you hear that the squire is in your town, run, 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 run. Run on down. Get your soul satisfied. Get your brain a little fried by the squire for hire. He'll naturally set your soul on fire. Get the groove. The squire's on the move, y'all. Oh no, he ain't backing up. He still ain't finished.
Like sweet surrender. Say slow down. Like sweet surrender. I've been waiting for you for so long, and now the time has come for me to live a life in peace and harmony. Nothing can change my mind anymore. Slow down, like sweet surrender. Slow down. places I've never ever been before. Oh, yeah. You, everything I want, and this is my style to tell you. Slow down, like sweet surrender. Slow down, sweet surrender. Slow down, like sweet surrender. Slow down, sweet surrender.
Well, all right.
Songwriter, producer, arranger, superstar.